CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs, from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now, for today's session, Get Your Money's Worth Out of Your Database by Patrick Barel. If you have any questions during this session, you can post your questions by using the chat window in your right lower side of your screen, and Patrick will be answering your questions by the end of the session. Also, if you have any issues during this session, please feel free to post your questions using the same chat window, and I will respond and help the best I can. Without more further ado, I would like to leave you with this amazing session by Patrick Barel. Patrick, and you just your microphone is off, like looks like you rebooted, and your session is not you're not sharing your screen. If you can share again.
Yeah, I'm supposed to be. Oh, where is that? Share my screen. Share this one. Can you see this?
Yep, it is all perfect now. I'm going to put myself in mute, okay, and the room is all yours, Patrick.
Okay, thank you. Okay, first up, a little bit about me. I'm Patrick Barel. I've been working with Oracle since about 97, doing mostly SQL. In 99, I started doing PL SQL as well. And I've been doing that ever since, just coming up on 25 years now. I'm mainly doing SQL and PL SQL. I played around with Apex back in 2003. But yeah, that wasn't a great success for me. I'll shut down my camera just to make sure with my head. I became an Oracle Ace in 2011. I was promoted to Oracle Ace Director in 2019, and that's mainly because I talk a lot on conferences in Europe, America, and in 2019 I got the privilege to do the APAC tour live. So hopefully that'll come back sometime in the near future. I also have written a couple of plugins for PL SQL Developer, my tool of choice. I think it's better than SQL Developer in a lot of ways. But some things aren't there, so I built them myself. I've also written articles. Sometimes I blog on my own blog or on the Quality blog. I've written a couple of articles for All Things Oracle, but the site doesn't exist anymore. And they moved my articles to the Redgate site, Simple Talk. I also had my own column in the OTech magazine, but that site doesn't exist anymore either. But you can still read my columns on my own website, the OTech magazine page. These are my contact details. I'll make sure the organization gets a PDF of the presentation so you can find me, find how to contact me. Like I said, I'm an Oracle Ace Director. If you want to know more about the ACE program, go to this bit.ly link, Oracle Ace program, bit.ly/Oracle Ace program. And if you want to nominate, well, it says here yourself, but I wouldn't nominate myself. I would nominate someone you know. Go to acenomination.oracle.com. A lot of things I'm going to show you today you can do in just about every database, but maybe you don't have access to the latest databases yourself. Sign up for an always free tier. You get 2 databases with 20 gig each, 2 compute VMs, a lot of block storage, and it's all free. Only thing is you have to log in every week or so to keep your databases alive. By the way, if you go to the Quality blog and you search for my articles, I've a 3-piece article written on how you can keep your always free tier databases alive using a Raspberry Pi and some Python code. Okay, topic of today: get your money's worth out of your Oracle database. Well, it doesn't matter how much resource you have, how much iron you're using, how much money you're willing to spend. If you don't know how to use them, it will never be enough. We didn't have access to all the compute power of the Exadata machines. Now we do using the clouds. But if you're not, if your company is not using the Exadata yet, or a cloud account, you can still get a lot of performance out of your Oracle database. Let's start with a bit of integrity. This can be done and has been available since Oracle, well, forever, in my opinion, since Oracle 7. We created a table, unprotected, with a couple of columns. We put in some data in there, and then we have 2 applications. One application with a front end with a front end attached to it, and me using SQL CL or SQL+. Let's say the application has a business rule: the salary should not be over 7,500. If you issue something like this, then the front-end application will prevent you from doing that, because the business rule has been built into the front-end application. But I can still do this using SQL CL or SQL+. Let's say we don't want to have any duplicate employee numbers. If I want to insert myself using employee number 7,900, the front-end application will prevent this, but I can still do this using SQL+. If I want to just want people to work on existing departments, if I want to update Scott to department 50, there is no department 50, the front end will prevent this from happening, but me using the SQL CL, I can still do this. When we're ready to build a new application, let's move some of the business logic to the backend, or at least also to the backend. We had this business rule: salary should not be over the 7,500. If we put a check constraint on our table, which checks if the salary is below 7,500, then both of them, both the application and the SQL+ session, will fail this update statement. If I don't want to have duplicate employee numbers, that is easy by adding a primary key constraint to the table, primary key on the emp node. And again, both will fail. If I only want people to be listed in existing departments, all I have to do is add a foreign key constraint. And if I want to do an update to department 50, both will fail. These are fairly easy things that can be done on every database. Flashback queries. Let's say we create a simple table. Again, employee number, e-name cell, and department number. Put in some data in there. And if we query back the data there, then we get to see what's in it, which is as we are expecting it to be. Then we do an update. We raise the salary by 200. If we then execute the exact same SQL statement again, we get the new information. If my colleague issues the exact same SQL statement, he will see the old data. And that is because I didn't commit. This is how we are used to working with the database since like forever. I mean, in my case, since 97, that's like forever. As soon as she commits, the person on the right also sees the new data. Now let's say we truncate the table, put in the data, and put the data back in, and she runs the select statement, gets the old data, runs an update, and sees the new data, and she commits. And then she thinks, oh boy, I shouldn't have. This is not the correct update. How can I roll this back? I have already committed. In this case, it's easy. It's just salary minus 200. But just imagine there has been a fairly complex calculation which cannot easily be rolled back. What you can do is you can select the columns from the table, add a timestamp, and then 2 timestamp. Give me the data as it was about a minute ago. This says sysdate minus 1 minute. And then she gets to see the old data. You can also say select as of system change number. And we always, before we execute any update, we always check the system change number, right? No, we don't. But suppose if you have access to the system change number, you can use this. This works out of the box. Depending on how busy your database is, you'll get somewhere between a minute and 2 hours of data you can look back into. If it's a really busy system, chances are you will not be able to go back any further than like 5 minutes or so. Temporal validity. Let's create a table with some employees in there. Put some data in there. And if I select, I get the data back, which is as we are used to have it work. Then I change employer. And I changed employer a couple of years back. So I want to update my employee address to the baan Kopstad. If I select that, I get new data there. Make sense? Yes. This is how we are always doing this. But remember, I know in advance I'm going to change employer. As soon as I do this update, it's changed directly. So how can I make sure I can use both the addresses? Well, we add a period for when it's valid. We alter the table, employees, add period for valid time. It adds 2 columns to the table. Those are hidden columns. You will not be seeing them when you do a describe on the table. But they're there because if you execute a query like this with the named columns, so the valid time start and valid time end, I get the 2 extra columns in my result. If I then update my employees table and set the valid time to end at the 31st of January 2018, a second before midnight, that means this record will be valid until the 31st of January. Sorry. I can then insert a new one, a new record with the same ID, same name, with the new address, only this one is valid from the 1st of February. If I want to see only the valid records, I would have to change all my SQL statements. And that's why where temporal validity comes in. If I say execute DBMS Flashback archive, enable at valid time current, so currently valid. If I then run the select statement, I get my address for my current employer. But I can also say, give me the information which was valid as of the 31st of January 2018. If I then run the exact same statement, I get the old data back. Of course, I can also say what is valid at the 1st of February, and I get the new data in there. If I want to see everything in the table, I can execute the DBMS Flashback archive, enable at valid time all, and I'll see all the records there. Be aware that you'll probably have to change your primary key. I'm guessing I'm using ID as primary key here, and make sure you include the valid from and valid to in your primary key as well. Data security. Oracle 12c comes with a for fee option, hence the $sign here, called data redaction. Let's say we have two people, a business user and a maintenance person. The business user can see the sensitive data as it is in the database. He can see all the information, so it's clear to him. The maintenance person, however, he can only see the last 4 digits of your contract data or your credit card or whatever. That's redacted, and we don't want to change anything in the database. So how do we do that? Well, we'll create a table with some sensitive data in there, the contracts. We insert a couple of rows, and what we then do is we add a policy to this table. Where does the object we want to add the policy to reside in the demo schema? What's the name of the object? The sensitive data. What's the name of this policy? So I can use this to enable, disable, and even drop the policy. What column do we want this to work on? In this case, the contract column. And then what function type do we want to apply? Redact partial. And some function parameters. I'll have to look these up every time I use them. But this says something like for all the information, the first 12 digits are replaced by an X, something like that. And when should this policy be enforced? As soon as the session user is not the business user. As soon as you execute this, the table has been locked. The DBMS redact partial, there are different redaction types available. Redact none, which is, I think, the most useless one in there, because I would then drop the policy. Redact full is everything's going to be redacted, so always all access. Partial is which I displayed here, and random will just randomly redact parts of your data. If this table is redacted, the business user does the select and gets all the data, all the clear data. If the maintenance person issues the exact same select statement, he'll get the redacted data. There is nothing changed on the database in the database. The data is always there. It's being changed on the way from the database to the client. Another thing which you can use is a virtual private database. Let's say we have a couple of records, some blue one and some orange ones. And this one group can see only the blue records, and the other group can only see the orange records. It's quite similar, but a little different. We have to create a function, a VPD function. The function always gets called by with two parameters. The first one being the schema name, the second one being the table name. The names of these parameters are not don't matter, but the order of them does matter. And what this function does, it will return a predicate. And in this case, if the user is the business user, the predicate will be the department number should be in 10 or 30. And if we're in the group maintenance person, then we get department number 2040. And otherwise, we'll just return everything. And this is an SQL predicate, which is added to the SQL statement that's being issued. Then I have to add this policy, which schema, where is the object? The object is called MVPD. What is the name of the policy? So we can drop it or enable and disable it. Where is the function located? It doesn't have to be the same schema as the object is located. And what's the name of the function? And if we then issue this select statement, automatically the Oracle adds the predicate where department in 10 and 30 for the business users, and for the maintenance people we get only department 20 because there's no one working in department 40. And there are a lot more security options available. Results, some performance increase. First of all, there's the query result cache. We create a table, put in 5 different values, and then we create a very slow function which does nothing but return whatever we put in there, but we sleep for about a second. And we set the timing on. If we query this very slow function on this table with 5 records, it takes about 5 seconds, which makes sense because 5 times a second sleep plus some extra work for network traffic. If we add result cache to the query, then all of a sudden it takes almost double, about 11.5 seconds. Maybe you're thinking, that's not a good idea. I want to have this thing speed up. But if you query the table again, the exact same statement again, it'll be executed in almost no time, which is, of course, a good thing. If we change the very slow function and make it deterministic, that's all I've added to the function. The first time it's about 5.5 seconds. Why it's speeding up, I don't know, but it is speeding up. And the second time it again takes almost no time. And the good thing is, it is cross-session. So if I'm running the query for the first as the first one during the uptime of the database, I'll take the penalty. I'll take the 5 seconds to get the answer. If Francisco runs the exact same query just 10 seconds after me, or half an hour after me, he'll get the results almost instantaneously. Next to the query result cache, we also have the function result cache. Let's create a function result cache table, insert 10 rows in this case, with 3 unique values, 1, 2, and 3. Create again the very slow function with the dbmslog.sleep in it. And if we query that, it takes about 10 seconds to execute. And for the other person, it also takes about 10 seconds to execute. If we add deterministic to the function, deterministic means if you've seen the exact same input parameters, you'll know the output parameter or the return value, so you don't have to execute the function anymore. So in this case, it takes about 4 seconds, which makes sense because there are 3 unique values, a little bit of overhead, and for it also takes about 4 seconds. If we add result cache to the function, it takes about 3 seconds for the first execution. But again, this one is cross-session, so it takes probably a little bit of time, but no time for the second one. And if I'm calling it again, it takes no time at all. Some special SQL features. If we want to retrieve the top 3 earning employees, you might be thinking this is the way we want to execute this. Select the employees, order by salary, and give me the first 3 rows. But this is not how it works. Oracle just grabs 3 rows and orders them. What you should do is you should create a inline view, order that by salary, and then get the first 3 rows. Or maybe do a with clause query factoring. In Oracle 12, you can now say, select my values from my table, order by the salary descending, fetch the first 3 rows only. And it'll give you the correct result. It is just syntax candy because the statement on the right is rewritten to something like the statement on the left. Probably a lot more advanced than what I can come up with. If we want to retrieve the next three top earning employees, we would have to use the row number between 4 and 6, but now we can use the statement offset 3 rows and then fetch the next 3 rows only. And this is great for pagination. Be aware though that if you go to, for instance, page 20, it means it'll have to execute the entire query and skip all the rows you want to offset by. So be very careful by using this. Another thing we know, when you use PL SQL and SQL, you're always hit with the context switches. If you create a function, and if you call that function within the SQL statement, you're hit by the context switch. There's a SQL engine and a PL SQL engine running. And as soon as the SQL engine sees the function, it will give control and some other data over to the PL SQL engine, which then does its work. And then when the PL SQL engine is done, it'll give control back to the SQL engine. When you're doing a table like this with just 14 rows, it's not going to be a big problem. You're probably not even going to notice all the context switching going around. But if your table is 100,000, maybe a million rows, then it's sure gonna be a performance hit. In Oracle 12, we can now create a function within the SQL statement. And there is still going to be a context switch, but it's going to be very much smaller. The hit will be very much smaller than when you're doing a real PL SQL context switch. And you get just about the same result. There are some pros and cons to this. The pros, it's faster, especially when you're doing large data sets. The logic is closer to its use. The con is there is no reuse of your logic. If you want to use this function in a different SQL statement, you will have to copy the function code. And if you have to change your function, you'll have to change it in all the different places. So there's pros and cons to everything. Virtual columns. How am I doing for time? Okay. Let's create a table and note the last column, the income column. It's generated always as the sum of the salary plus the income. And it's going to be virtual. If I then insert a lot of data into this table, please note that you're not supposed to insert anything into the income column, because the income column is being calculated by the database. And if I then select everything from the income column, you can see there it is. It's performing the sum of the two values. You can use a virtual column. We've seen virtual columns. Sorry, that was hidden columns. You can use virtual columns to make sure that nobody does a select star from your table. If you add a virtual column, in this case called blow it up, and it's generated always as 1 divided by 0, if you then insert data into the table and I do a select star from the table, I can never get to the data. I always get the error divisor is equal to 0. But if I know all the columns, in this case the empno, e-name, salary, and department number, I can still see my data. You're probably thinking, it's all well and good. You're telling me how to use this, but I'm not able to use an Oracle 19C database for my own playground, and I don't have access to any other databases. Well, you always have access to the Oracle Cloud. Oracle provides us with Live SQL. LiveSQL.oracle.com is an environment where you can learn and share your SQL. You can create a lot of, if not all objects, tables, views, packages, triggers, anything you can think of. Only thing is, if you log off and log back on, it's all gone. You'll get a new clean sandbox. So make sure you save your all your work in scripts, so you can try them again and run them again, maybe edit them, and if they're very good, you can probably share them with the community. But on the other hand, you can always use the always free tier, like I said before. Remember the good old days when we had a table with a unique column. We had to create a sequence for the unique column to be used, and then we had to make a trigger where we can make sure the unique column is filled, getting the sequence in there, and connecting the sequence to the trigger to the table, and then the unique column would be filled sequentially and uniquely. In Oracle 12, we can add a column and have it be generated always as identity. So instead of building a sequence, there's no need for that anymore. Oracle creates a sequence under the covers for us. The trigger, there's no need for the trigger anymore. Oracle makes sure the column gets filled using the invisible sequence. So I think it's memories of the old days, not necessarily the good days. Invisible columns. Let's say you have a table and there are columns you might want to drop. And you know, if you drop columns, the data is gone. Even using the as of syntax. If you drop the column, the data is gone. But there's another option. I'm creating a table. I am the important man. Add the data there. If I select star from this table, it'll show me I am the important man. If I then alter the table and modify the column important to be invisible and execute the select star again, important is gone here. I am the man. But if I know the different column names, I can still get to the data because I can still select all the different columns. Be aware that if you make the column visible again, it'll come up at the end of your select star. So it'll be I am the man important. How am I doing for time? Whitelisting. Let's say you have a procedure where you only want to be have accessible by a special other procedure. In this case, the normal procedure. Yeah, then you have the accessible by clause. So this only whitelisted is only accessible by normal procedure. Create the normal procedure, and that calls the whitelisted, and that is okay. Then we create an evil procedure, which also calls the only whitelisted procedure. And that will not work because evil procedure is not in my accessible by list. If I change my evil procedure and have it call the normal procedure, which in turn calls the only whitelisted procedure, then I'm still able to execute it. I'm gonna skip the polymorphic table functions for now, for time's sake, because we only get 5 minutes, and that's an entire that's an entire presentation in itself. This one. SQL Macros. Oracle 19c. This is actually a 21c feature which was backported into 19c. Let's say you have some documents and you want to calculate hash values from them or from columns in there. And you'll have to execute something like this. And I always have to look this up. Use crypto hash source using the string to raw, and then the character set type equals 2. I have no idea what that means. And if I want to do this for the departments, same statement, only different fields. What if I can put this into some kind of a template? And that's a SQL macro. Let's say I create a SQL macro, create a function, add hash. The table is the table on which I'm working, which is of the DBMS table function table type, which is actually the table object, not a string. And this one will return a SQL macro, a varchar SQL macro. And what in this function, I'm going to go into the table which has been sent in, so emp or dept, and go for all the columns, check the data type, and if the type is varchar2 number or date, this is my choice. If I can use this column, then I add the hash string, add the character, the toolbar from the column with the name, so the different column from the table. And then at the end, I'm trimming the pipes from our string. And here is the function which we saw earlier, DBMS crypto hash source string to raw, and this is going to be all the columns, the character set, the type, MD5, and we'll call that hash value. Then select t.star everything from my table. And if I then execute this statement, department hash, it'll give me the hash value for these 3 columns. And if I execute this on the emp table, it'll give me the hash value for all the columns in the emp table. If you want to take this a little bit further, you can build a very sophisticated SQL statement or SQL macro script, which in the end comes up with just about the same as before. And in this case, I can say select from the table dept and use these 2 columns to hash. And if I execute the same statement but with the 2 columns in a different order, I get different hash values. So that's it. We talked about the integrity. We talked about some flashback queries. I told you a little bit about temporal validity. I've shown 2 data security options. We had something about performance increase with the result caching, some SQL features, build SQL in your with clause, the virtual columns, the identity columns, and the invisible columns. some of the whitelisting. I skipped over the polymorphic table functions, and I showed you something SQL macros. And that's it. Are there any questions? I have not seen any questions in the chat. So if you want to play with this, get yourself a free database on the Oracle free tier. And thank you for your time.
Hi, Patrick. Thank you so much for a wonderful presentation. Up to this point, we have no questions, but the people have the tendency to ask the questions later. And if anyone have any questions for Patrick and don't want to publish to the chat, but want to contact him directly, please feel free to do through his email or through his Twitter handler. If you cannot reach him, you can pass that to us, and the Apaco UC be more than happy to relay our questions to Patrick if that's the case. If you're watching the replays, they will be available until the December 30. Please feel free also to contact Patrick directly at any time. And saying that, I would like to say thank you so much for Patrick, because we are just taking time from his lunch. That way he can go and eat. And also, thank you so much, Patrick, for sharing a lot of interesting topics with the community, not only the Asia Pacific, but all around the globe. And please take care and be safe, everyone, and Patrick, you too.
Thank you. Bye.
Have a wonderful day, morning, or afternoon, or evening, everyone, depending where you are in the world. And thank you again, Patrick, and have a wonderful day in Netherlands today. Bye, Patrick. Bye, everyone.
CloudDB, shaping your new normal.